Hello and thank you all for joining us today for this educational Innovise webinar. My name is Caitlin Nyan and I'm part of the marketing team here in the Innovise Portland office. In this webinar, our presenter Zach Sample will discuss how sustainable stormwater infrastructure and all its acronyms can easily be incorporated into a design and assessed along with the rest of the stormwater water mitigation system on a development project. For those of you who may not be familiar with Innovise, we have a long history of providing high-performing, innovative software solutions. Our intention is to make sure that in your work you can design, model, review, and manage with confidence. This also means that we strive to provide excellent customer service and support, and that we offer continuing education opportunities like these for engineers and others in the industry. Innovise offers a library of software programs for the design, analysis, and management of water infrastructure, including powerful storm and flooding modeling software like XP Drainage, which you will see today. Now on with our presentation. I'd like to introduce our presenter. Today's presenter is Zach Sample, one of our stormwater product managers. He has over 10 years of civil engineering experience in site design, stormwater planning, and hydraulic analysis. Zach has performed a number of advanced water resource studies, including hydrologic and water quality system assessments, as well as 1D and 2D hydraulic river and floodplain studies. During this time with XP Solution and Innovise, Zach has helped hundreds of clients with their models, conducted training courses, and led the development of our stormwater design software, XP Drainage. Thank you again for joining us. Would you like to start a discussion, Zach?
Yeah, I do. Yeah, thank you, Caitlin. Thanks everyone for joining. Let's jump right in to what we'll be talking about today. So pretty broad subject matter. So we'll start with, we talk a lot about, and I'll mention green infrastructure and LID, this and that. And so we'll talk about even what in the world these things are. Get into how we're advised and how it's recommended to design some of these systems. And most of the time will be just spent on really just looking at the whole range of different, what I'll call stormwater controls that we can implement successfully on sites. Ultimately, just briefly show an example of what I consider a more complex site made a bit easier. So showing a range of different these facilities. So to start, before I go on, actually, I'll remind you all there's a questions field that I will try to glance at and multitask as I'm presenting and see if there's a question I can answer while we're moving through the presentation. Certainly anything that I don't talk about or bring up during the presentation, we'll talk about at the end. So don't forget there is a questions field that you can kind of engage with me and everyone else. So acronyms. So we as engineers love acronyms. So there's a whole range of these letters. So LID, GI, BMP. So those are most often used across the US. Low impact development, green infrastructure, best management practice. If you perhaps are in the UK, there's the sustainable drainage system, SUDS, or WSUDS if you're in Australia. So all these systems are really all talking about the exact same thing. And there's even more terms that I haven't put up here. I think there's even LIDS perhaps. They're all talking about the general larger scale practice of sustainable and holistic development of sites, right? So this is more than just, a rain garden. We'll talk about that in a minute, but this is the site as a whole and the community as a whole. How can we continue to improve and augment our infrastructure and the area around us, in this thoughtful way? So those are large practice ideas. I'm going to specifically call an individual facility a stormwater control. So that's a pond or a single rain garden, a stormwater control, versus green infrastructure, which is this larger notion of sustainable design. So post-construction runoff control BMPs. So I'll note that specific language is used quite a bit. This phrase comes from the NPDES NS4 minimum control measures guidelines. And there's a whole webinar that we could talk just about the MS4 permitting, how those came to be. Well, in fact, actually, I did do that, I believe, last year. We have a webinar on that topic, but that's where a lot of these notions come from, okay, is this post-construction, right, permanently in place practices. So a couple items here. The main umbrella is we're trying to maintain the quote-unquote natural hydrology conditions. So whatever the site was like before we began to augment it, pave it, move stuff around, we want to continue to have that hydrologic cycle, right? Rain lands on the site, a little bit infiltrates, actually a lot infiltrates and a little bit runs off. Water hydraulically then moves through our streams and our ecosystems. So we want to maintain that. Part of that practice is with GI techniques, green infrastructure techniques. And we'll look at these in a moment. So bioretention, grass swales, infiltration trenches, so on and so forth. But what I want to call out is that, that larger scale best management practices, green infrastructure, it's not, again, just a couple ponds, right? It's a larger practice of distributed treatment across a site, okay? That might be back in the 70s, the bread and butter was to put just one giant detention pond at the end of some sort of drainage catchment. Well, that's really not an effective way to treat, as we'll talk about, and maybe not the best use of space. So distributed smaller facilities all across a development. Also, maintain a site layout that's really mimics and follows what the natural drainage paths were. A lot of reasons for that. And also this holistic planning point of view. We can maybe get away from curb and gutter and let water sheet off of some areas and get back into the ground. Maybe narrow residential streets. Roadways are often the most impervious coverage, right? So if we can narrow and limit those streets, the imperviousness, okay, well, we'll really, from a design point of view, be asked to treat a lot less, right? Usually we're trying, and we'll talk about this, but we're trying to mitigate impervious runoff. Well, obviously reducing what imperviousness there is would be a big help. So what does this look like here? I'm going to point to the Georgia Stormwater Manual. I might call it the Blue Book. I think that might be a term some people use. That is one of many great resources. I'm physically located in the Portland, Oregon area. Portland has a lot of great resources on this concept of holistic planning. A lot in Georgia, Minneapolis has guidelines all over the country. There are really great resources, and municipalities often have a lot of description about why this kind of stuff matters beyond just the actual design guidelines. So you see here, we go from on the left is maybe kind of a classic subdivision. Everyone's lots are exactly as big as they can be, and there's one big pond. The issue here is this doesn't feel like a good communal space. There's not perhaps a lot of walking, not a lot of, I guess, community engagement points, and probably some stormwater issues, some backyard flooding, okay? Well, on the right, we can have as many lots and preserve, don't infill creeks, right? Keep these natural corridors, natural vegetation, and we're gonna have a lot more aesthetically pleasing, a lot more of a kind of that community feel to these developments. Similarly here for commercial, great, we can go in and just put the big parking lot in the middle and clear the land and plant a couple trees. Or on the right, we can really work with the natural site, keep as much existing foliage as possible, and have that parking lot move around the facility. All right, so now I want to get everyone's thoughts, and I'll share this. I always like to get, I guess, all the audience's thoughts, or I guess in this case, hearing what experience people have coming into this webinar. So go ahead and click one of those buttons, and basically it goes everywhere from, I might say, you have to or get to incorporate green infrastructure on all your projects. Maybe all this depends on the area or client. Maybe it depends on the client. Maybe you have a city that would require this work, except for maybe an industrial zone or a shipping area. So depends on client, but it'll be interesting to see. I can already see the numbers coming in. It's very similar to our earlier presentation, where we had a kind of a similar bell curve. And certainly if you've never been required by a municipality to do this work, well, you're probably going to have to soon. This is really across the board, across the US. Areas where there might be guidelines at the moment, which is kind of a, hey, could you please do this? It's going to be a, you have to do this. All right, so I'll close the poll and I'll share. You see kind of a bell curve look to this. Not everyone has to do it everywhere on every single project, but most people have seen this and used this to some degree. So let's keep marching along. Looking at sizing criteria, like most of the work we're doing, when it comes to stormwater, there's really this kind of pre and post analysis. So I'm going to call out this hydrologic analysis, though really I'm talking about hydraulics, but I'd like to think of the water cycle, that kind of hydrologic, rain falls, some infiltrates, some runs off. The main idea for this, for BMP and really stormwater sizing, is whatever flows existed before, well, you can't really exceed those. So that is also changing, where developed flows and the volume of runoff of your developed site can't exceed the existing volume. So that is actually really difficult for developers, for designers to figure out. All right, so it's not just knock down the peak flow. We found that detention ponds don't really do a good job of truly mitigating the impacts downstream. There's lots of stream erosion, lots of water quality concerns. So now we need to retain and infiltrate a volume, to keep our discharge volume less or equal to our existing conditions. So that's where we really begin to need to have some of these green infrastructure practices to do that. So the first design, water quality would be, and a lot of this, again, I'm going to point to the Georgia Stormwater Manual. This is pretty much the same across the US. Slight differences. In this case, the first flush water quality volume might be the volume to size your individual stormwater controls. Let's say it's about an inch of rain, 1.2 inches, maybe 2 inches some places. But in general, there is an amount of rain that that volume you need to infiltrate. So the odd thing that I always found was, we're talking about water quality, but we're not directly talking about pollution. There are some areas, there are actually quite few, where you're going to have a specific pollution concentration that you're trying to reduce to. Usually in our design, it's still a volume problem, right? And you can even assume with a concentration of suspended solids or total nitrogen, total phosphorus, fecal coliform, even trying to track those pollutants, we might still assume, all right, any flow that, let's say, drains through a rain garden or a bioretention facility, we're going to assume 100% TSS is removed. So even then, it's still a kind of a percentage removal, or just a, if you can get it through a facility, then it is okay. So that's how we usually size our water quality facilities. Then we get into some higher rainfall events. So we might call this the channel protection, ultimately overbank, and extreme protection events. So the idea of the channel protection would be, I guess, going from the description in some of these manuals, would be provide extended detention of the 1 or 2 year storms released over a 24-hour period, right? So this is to reduce bank full flows and protect downstream channels. So hey, more minor events, great, protect the channels. As we get higher and higher, right, the 25-year event, okay, we're trying to safely pass that flow downstream and not flood anything else. The 100-year event, well, I should say, the 100-year event, this is being discussed quite a bit, right? What is the extreme event scenario? I feel like Houston is an area always picked on when we talk about stormwater and rain. If you've had an area that had the 100-year storm 3 times in the last 5 years, well, maybe that's not the 100-year storm anymore, right? So some places have been applying an amplifier to just kind of account for, where the rainfall has historically been occurring. So maybe the 100-year event needs to be amplified. Regardless, you get the idea. We're looking at these different levels of storms, and starting with water quality, a more minor event, all the way up to flooding, safely mitigating these flows. Now, why aren't LID systems designed for flood protection? Well, we'll talk about that, mostly because these facilities have some sort of filter layer, right? So there's some sort of filter zone, and you can imagine, go to a playground where there's a sandbox. If you dumped a lot of water through that really fast, so a high flow event, that velocity for those events will just wash that sand away. So that's why sometimes these facilities can't be used for flood protection. That said, there are a lot of facilities that can, and we'll talk about that. I might call those dual purpose facilities, okay? So let's jump in to our stormwater control options. I'm trying to cover a lot of information here, and these 7 different types of facilities. So with the time given here in this format, I'll march through what they are, why they are, perhaps some consideration to take into account, and obviously questions that you have along the way, go ahead and type them into the questions field, and if I can't get to it while I'm talking, I'll absolutely talk about them at the end. So the first, I tend to call this a rain garden. It's a bioretention area, biofiltration. Those are all the same thing to me. And the very dry definition, vegetated depression that collects and treats runoff. Doesn't inform me a lot of what it is. The image on the right is maybe a little more informative. Okay, so this is basically, a vegetated, that's an important part here, a vegetated kind of ponding area where water can pool up that includes some sort of filtration. That's what makes these, that's what makes a rain garden, is that you have filtration occurring. So usually there's sand and washed gravel filter media zones, okay? These highly customizable, even when it comes down to what kind of plants are being established there. So plants are super important. They're going to control that sediment and not let that sediment wash away. You can also stabilize that soil with, fabrics and whatnot. So that's maybe a common practice to have plants and fabrics. But the plants also, their root systems are going to be absorbing nutrients and allowing infiltration to occur better and better. Something I'll talk about maybe more at the end, but establishing these systems, I know there's been a number of cases where facilities that were planted 30 years ago, not only with minimum maintenance are still performing, but they're actually performing better than when they were initially planted, right? Because of the establishment of the vegetation and, minor but, somewhat frequent maintenance. These facilities can last a really long time and get better over time. Rain gardens, biofiltration, I'm going to call it the best pollution treatment. Like if we were actually worried about removing, pretty much name any pollution concentration washing into a facility with, a couple, maybe a couple this isn't the best for, but phosphorus, nitrogen, TSS, this is usually kind of the bang for the buck facility. And something in the first webinar this morning, someone asked, my general, when I was a consultant, if I had literally 30 seconds to figure out the even starting size for these facilities, I tend to go with, between 2 and 4% of the impervious area washing into this facility. That's, depending on where you are, generally a starting point. So if you could say, all right, 2 or maybe 4% of that square footage, all right, you're gonna need a facility about that size. So some thoughtful applications, these can be used a million different ways. One really common one, some retrofits, maybe more urban areas, wherever there is a kind of a curb inlet, great. Cut back that sidewalk and you can have maybe a tree box or a flow through planter, really common. There's lots of groups that make those devices. So I happen to be living in Portland, Oregon. There's a Green Streets program here that's really across the country, basically targeting some of the kind of in between the road and the sidewalk. There's that little strip of land. Well, if we convert that into a rain garden, we can have distributed cleaning up of our stormwater all across our urban infrastructure. Really great way to do that. Basically, any interception of impervious runoff, you could have a rain garden. Okay, that could be said for many of these stormwater controls, but you can put a rain garden in, almost anywhere. So some design considerations here. Well, one of the pieces that we need to look at, and which is often not looked at, and I would call out probably the root of a lot of our problems. A lot of our problems being, right, like the long-term maintenance and success of this facility, our ability to actually, as a contractor, build it in the first time. When we're designing this, to actually assess the flow, the hydraulic flow through our media and under drain, and ultimately the high flow outlet, right? I mentioned the sand might get washed away, so there needs to be a diversion with even the 2-year rainfall event needs to be diverted so that it doesn't wash through this facility, okay? Well, I have firsthand seen this a number of times and gotten calls myself from people out in the field. It's not a very pleasant phone call when the first rainfall event, right, these facilities are washed out. You don't want to get that call. We need to actually, I'm going to say this a million times today, but hydraulically analyze what's happening. And yes, these facilities are complex, but that doesn't mean it has to be hard to do, right? So you can't just say, all right, here's the volume of a rain garden. We'll just magically figure out how to divert the high flows. Nope, you've got to prove it. You've got to show a simulation, a design to really communicate what you're going to do and how it'll work. Another piece here, the in situ soil capacity, right? So the soil underneath your facility might be able to help you out. So you might be able to get some infiltration in that soil, or the opposite. Maybe you have a lot of clay-y soil that won't infiltrate very readily. You got to account for that. Slope stability, if you're trying to put a rain garden on the edge of a kind of a steep roadway, you're probably going to want to wrap that facility up so that you don't have infiltration, unless you want to wash the road away. That's another, pretty hard phone call to receive. So you don't want to wash out any infrastructure by infiltrating where you shouldn't. The biggest one with rain gardens, so they can be the absolute best facility for truly treating runoff. Though this, because it has combinations of really all the rest of the facilities, it's kind of a pond, it's kind of a filter, it's got under drains. This, like all of them, but especially this one, everyone who's going to interact with this facility needs to know. This is part of that holistic implementation of sustainable stormwater, right? So there's public education, there's education from the maintenance crew on how to maintain these plants, maintain these facilities. So the designer, the planner, the contractor, the public, and not like, the review agency. I mean like actually the citizens that are going to live on that street. They need to know why these exist so they can help support these systems. Right? If people don't know and can't appreciate why it's important, they aren't going to care about it, right? And it's going to get garbage dumped in, it's going to not be maintained well. So that's really paramount to this, okay? And that's paramount even for a detention pond. But this is a real focal point for a lot of communities, so it's very, very important to have that information. All right, so next on our list, permeable pavement. So this is porous, basically anything you walk on or drive on, right? Porous asphalt, concrete, or pavers. You can think of this as like a no fines aggregate mix, or just spaced blocks. The image on the upper right shows these kind of like those brick pavers with a fill underneath. This is great because it is going to increase your developable area, right? So if you are trying to, if you're kind of hitting a wall and you can't quite develop more of your site because you're getting too much impervious area, well, clearly your big parking and roadways, maybe you can make it impervious. This is going to obviously reduce the runoff from these areas. Another one is actually, there's some pretty key pollution metrics that this is going to help out with. So a big one that someone might not think of is temperature, right? So I'm in an area, physically important area, where the salmon is king. The waterways are so important, and reducing the temperature of these waterways, it has never been more important, even across the country, right? Having waterways get warmer and warmer is really causing havoc, right, on those ecosystems. So it rains, water gets right down into that subsurface, and we're going to preserve the temperature. Some thoughtful applications, basically any place you're going to walk or drive, you can do this on your site. This is even, I've personally worked on a project, fire lanes, right? You need a fire truck or an ambulance, really heavy machinery. Well, you can still, have a pervious structure. You can even have grass planted in these areas. You can't even really tell that there's a road there. Obviously, there needs to be signage for those emergency crews, but you can even have fire loops, fire lanes, be grassed if you use a porous facility. Another one I've seen a lot of talk about, a lot of success with some DOT departments, using pervious asphalt on major arterials, major roadways, makes them much safer, reduces the spray dramatically. And a lot of the groups I've seen, they've said that there's no need to maintain these any more frequent than a regular, typical, I'd say, asphalt application. What is it, 5, 7, 10 years, whatever it is for that area. These pervious surfaces are following the same, O&M plan. So it's really, really great. The important item here, though, freeze thaw, a lot of studies on this. Might be the first one I always think of. Actually, it's nowhere near a factor. Sediment load is a factor, right? So if you don't educate the community, don't have signs for kids to understand different languages, you might have someone, dump soil on a site, and maybe they're having a project and they're moving dirt. Well, if you put dirt on top of these porous structures, you're just going to fill it right in, and there's no vacuum truck that can get it perfectly cleaned out once you do that. Design considerations. This is actually a really complex facility, right? So the hydraulic behavior, again, I'll say this for every facility, but you have to assess this. There's flow through each filter zone, right? Flow along the filter. There might be under drains, and there might also be curb cuts. There might be kind of diversions if it gets flooded, right? So if it does get blocked up, you want the water to still get out of your parking lot. So that's a really complex facility, and it's almost never assessed, and that's why a lot of these things fail. Having the backup plan for if they get clogged, those kind of things need to be assessed. The important item here, site slopes. Well, in a parking lot, there's often some sort of even 2% grade to that parking area, even with pervious asphalt. So you can't just say, all right, this is a 2-foot deep, structural fill with 40% void space. Here's my volume. No, you have to know that it's down a 2% slope. So your retention volume actually is much less. I mentioned this before, but account for the true layering of the structural fill and the flow through it. Really, really important. Okay, so swales, vegetated depressions that collect and treat runoff. Okay, basically, every ditch that runs along any country road you've ever been on, well, that's what we're talking about. Those are all swales, right? Vegetated grassed channels. That was a swale. Now, this could be a ditch, could be a bioretention system. So this is one of those kind of dual use facilities. So you see in the lower right, that image is showing a swale where someone has excavated out the base and put in some sort of infill so that the water can drain down through it. That can obviously treat your water quality event, but if you can kind of anchor that sediment where it is with fabric, what have you, well, that can also be your kind of high flow drainage corridor. That could be an attenuation facility. So these are extremely common collection facilities, right? Swales and ponds are very, very common, though they're usually not filtration systems. So as I mentioned, can focus on, if with some retrofit, just some modification to an existing system, under drain, some pea gravel and a filter fabric, you can have this be a dual use facility. Some thoughtful applications beyond just next to the roadway. Well, what about a center island in a road? Maybe there's turn lanes. Well, maybe you don't need to have a turn lane every single foot of that middle lane. Maybe you could have some islands that also has whatever traffic calming, so to speak, making people more aware of what's going on. So center islands are a great place for this. That double duty dry swale. So swales with a filter zone in the middle. And really, walking corridors and swale, it kind of goes hand in hand. Kind of meandering paths and meandering green infrastructure are great items. Design considerations. Well, again, if most of these facilities run along a slope, well, again, you can't just go, all right, my swale's 3 feet deep with a 1 to 3 side slope. There's my volume. No, it's not going to fill up like that, right? If it runs down a slope, it's only the very end of it will really pond up if it does that. Something to keep in mind. Storage capacity versus space, right? So again, if you have a volume requirement, you might need to make your facility bigger, maybe make it shorter at the top and deeper at the end. Okay, that's another way to really balance the true volume storage. For swales in particular, well, you need to maintain these. Usually they're grassed. You can see in these images, someone probably needs to be able to mow the sides of that grass. So having it be gently sloped, 1 to 3, 1 to 4, usually accommodates that. So the quick question here about, will I be showing this in XP drainage? So at the very end, I'll be touching on how these look in XP drainage. The point of today is a lot of just kind of education and talking about these facilities. But we'll look more at XP drainage at the end. Any questions that I don't answer, obviously, I am more than happy to dive in and to compare this to perhaps what you're doing now or what you're not doing now. From my experience and my experience as an engineer myself, as well as the I don't know, probably over 1,000 engineers I've worked with at this point. So green roofs and rainwater tanks. This is a pretty interesting topic. So the idea here, a vegetated roof area or a kind of a downspout tank. Well, the point of these would be that you can directly reduce the runoff from your site and attenuate peak flows. In fact, you can, have excess water, right? Of course, flow through the roof area, right? All that, the soil up there in your tanks. Obviously, you can store this water for usually irrigation, for watering of a site, right? So gardens, car washing, toilet flushing. Now, the rub, so to speak, on this is, in my time, I've never got to say, all right, we want to retrofit a site. I think you should put a green roof on that building. Well, usually a green roof is something that is designed and laid out as part of the building structure design. And usually this is part of the lead certification. So LEED accreditation is a really cool system. I recommend you check it out if you haven't heard of it. There are some stormwater components, though it's largely for everything on a site, mostly the building. So you get a lot of points and a certain level of accreditation based on what you implement. Well, a green roof will be one of the ways you could keep the building temperature stable, so on and so forth. But it's hard to retrofit a building or basically just go, hey, let's just put this really monumental dead load on top of a building. Yeah, it might not work out. So vegetated roofs are something that's really before the building is constructed and designed. That's when that gets itemized. Rainwater tanks, on the other hand, well, I could put this on my house, right? You just walk outside and you kind of bolt a tank to that downspout. Though across the U.S., some places it's illegal to do that. Some places you have to. I worked in Australia for a period of time. They went through a 10-year drought. Well, turns out you go through a drought like that, it becomes required to manage your water effectively. So every building had to have a rainwater tank, okay? One of the main reasons that rainwater tanks aren't allowed is vector control, bugs, mosquitoes, right? So if you don't adequately keep a filter on top of these, you might have a lot of mosquitoes grow, and that is a real issue. So thoughtful applications, again, any existing building can get a rainwater tank. The item here, though, for rainwater tanks in particular, they might be considered full during your design, right? Like the absolute worst case scenario is that it rains a little bit and then 2 days later it rains really hard, right? So that first rain fills up your rainwater tank, then the proper rainfall event hits. So, in many cases when you're designing, your rainwater tank isn't allowed to be used for a volume reduction device. And if you are designing this, well, you got to take into account the drawdown rates, tank volumes, and really what kind of overflow structure you're going to have. Okay, moving right along, ponds. Everyone probably knows what a pond is, right? But depressions, they collect and mitigate runoff. Now there's dry ponds or wet ponds, and this is the most common end-of-line facility, so to speak. A dry pond is very similar to that dry swale. Well, there's some infiltration which can occur, right? Within 24 or 48 or 72 hours, within 3 days, that facility will naturally infiltrate the volume. Wet pond just means it's, predominantly wet most of the year. Huge range of facility types and shapes and configurations, okay? Applications, well, a feature pond. If you have some sort of development of any kind, having a pond or perhaps a wildlife refuge, really great kind of focal point for your site. Another item would be, I mentioned, you can have maybe smaller ponds if they're dry, right? If you can have some filter, right? Amend that facility with a filter zone and kind of anchor that sediment there, you're probably going to have a more effective, even just detention facility. You have a lot smaller footprint if it's dry, okay? So design considerations. So a huge range of volume sizing criteria and rainfall events for ponds, because they can really be water quality devices and extreme flood protection devices. So I'll call out, in addition to all the different types of uses for these facilities and their usually quite complex outlet structures. You might have an orifice for every rainfall event and a weir and so on and so forth. Clearly, we need to have a very real hydraulic analysis of what's happening here. Underground detention tanks and chambers. So, plastic, steel, precast. These are pipes and boxes and arches. And even milk crates. I don't know how else to say it, but a milk crate device, people probably understand what I'm talking about. The lower right image shows that, stackable structures underground. So this is really, for many people, the panacea, right? If you're doing commercial development, you might have a large anchor tenant, middle of your site. And okay, usually you would need to have a pretty big detention pond or even several large clumps of rain gardens and treatment. Well, what if you can have your detention facilities underground? Well, you're going to have a lot more area for parking, and you might even be able to have, another smaller tenant on that site, maybe a restaurant. So underground detention has been around for quite a while, and there's a reason that it's, I guess so common. Is it on a commercial application? Very, very, very useful. So a couple items to consider when designing, what's the real void ratio and what's the infiltration beneath that facility? So you might have some in situ soil where even an inch or two an hour can really reduce the volume that facility needs to hold on to. Clear to hear, like all these, a real hydraulic assessment of actually, how this facility will be put together, right? Where the orifice is, where items daylight down into these tanks, those matter. Okay. So marching along, for the sake of time, talking about maybe for some people a less common underground injection well, dry wells might not be used as common. So the underground injection facilities are often a big permitting. There's a kind of a burden on permitting these items. The idea here is that, well, you're directly taking surface runoff, which might have oils and heavy metals from car brakes. You're taking that and you're putting that right down into the groundwater table. Right? The issue is that normally water has to infiltrate down through soil, and if you didn't really know, that's basically how all filters work. You can go to a facility that filters drinking water, and for the most part, they're running that water through a bed of sand. Okay, maybe there's some activated charcoal, but moving down through soil. I guess it's soil if you have a degree, and it's dirt if you don't, right? But moving it through soil, that's how you're going to treat this water and clean it up before it gets to the groundwater table. Directly infusing the groundwater table with potentially pollution, well, that can be a concern. So strictly regulated for that reason. A way to get around that would be to maybe pre-treat. So if you have, instead of having water drain directly into this facility, maybe you have your rain gardens and you have good quality treatment, which then can be directly infused down to the groundwater table. Okay. When we get into actually designing this, the idea of assessing the different filter media and different soil and different infiltration rates are really key to understand how this is going to behave. So infiltration trenches. So this, media filled trench, right? So that's not a very descriptive sentence there, but this is basically high void media with an underdrain, okay? Now there's a lot of applications for this. So let's say if we are doing some sort of mining, right? You might need to dewater your site, maybe construction phase. That's what infiltration trenches are great at. They're basically rain gardens without a ponding area, right? Water gets right to this trench and goes right down. At the edge or along the center of impervious areas, water can sheet to the middle of the road, perhaps, down one of these trenches. Pervious walking paths are a direct example of this, okay? Another example, airports. Airports sometimes need really flat infiltration. There's de-icer, there's all sorts of spills that could potentially happen. So treating that water might be very important. So infiltration trenches and rain gardens are really, for airports, pretty important item to implement. Considerations, well, you've got to really assess the hydraulics of this system. Under drains, the material, likely there's a filter fabric involved, right? So we need to be able to assess those. And again, above and below the facility. Maybe there's soil underneath, which has some infiltration capacity, okay? All right, so pipes, channels, bypass. So this, plastic, metal, concrete, even vegetated conveyance systems. So we're talking about green infrastructure, right? Well, I don't maybe commonly think that I'm still going to need a a plastic pipe, but you are, right? So there's always a need to move water from one facility to another, or really just move that water into maybe a more central system. That's what these do, okay? So they aren't gone, they're just thoughtfully implemented. So often, I mentioned rain gardens need a bypass. They need to, get the high velocity flows out of that facility. Well, a bypass channel is probably the most common way that's ever done. So you can have that water dump out and go down a channel to some other collection facility. Well, design considerations, even in a standard traditional layout, where you have a pipe network dumps into a pond, this is still important, but especially when you have a distributed stormwater system, or you have smaller ponds and facilities all across your site to give you more space and developable land, yet still meeting your pollution reduction. You need a comprehensive analysis to assess that, right? It's not enough to say, all right, well, how big should this pipe be? Done. No, you've got to see how the flow and the timing throughout the network, throughout these ponds and rain gardens, how that all impacts each other, okay? Because they will. That's that basic pipe sizing versus really the integrated hydraulic design. An important item here is the idea of an as-built level assessment. I can't stress that enough. If you're representing green infrastructure, there's so much, I guess, simplifying, dumbing down, so to speak. Oh, this is complex. Let's just make this simpler. Well, we might do that so much that we're not really representing and assessing what's going to be in the ground, right? So that's assessing the real lengths of pipes. That's assessing the actual outlet locations. Okay, that's all going to add up together and make an impact on your site. So in summary, all these systems really need kind of the following. I've mentioned it a number of times, but a robust hydraulic analysis on that as-built level, showing truly where the filter will be, the ponding zone, bypass channels. Well, since these facilities can be so customized, well, I guess it might go without saying, but you need to be able to assess them differently on every single project, because they will be different on every project. Tie-ins, right? You're going to have where systems tie into each other, daylight out. Those are very complex, something configured out differently in every site. Flexible control of infiltration and filtration is something really important to readily assess on these as well. And ultimately, we can have the best design in the world if no one gets it, right? If you can't communicate that to the city for them to sign off that, yes, you're not crazy, yes, this will work. If you can't report that, if you can't communicate that to the city, to the contract, or sorry, to citizens in the community, to the contractor, these systems won't get built correctly. They won't get loved and appreciated, and ultimately, if a facility is not loved and appreciated by the community that it's put in, it's not going to work. It's going to fail, and that's a huge burden on municipalities that own these facilities to keep these systems clean and maintained, right? So I'm going to jump in just briefly into showing, I guess a more complex site, just to show that there really might be 4, 5, 6 of these different types of facilities all in one place. So this is XP Drainage is the tool that I'm using here. And I might just turn off this background image and jump right into this site. So here's an example of, here's this catchment area. And we'll see that I happen to have pervious pavement, which all drains down into this network along the side of rain gardens and swales and ponds. So let's look at, so here in this example would be pervious pavement, something that normally, in my past life, when I used Excel, it's hard to design this. Well, the point is to directly assess, as it will be built right in the software. So you'll see here that here's the image showing what's going on. And here's the footprint based on how I drew this facility area. Well, all these attributes are kind of updated for me. So I said it's 40% void space. I said that it's perfectly flat. I specifically denoted that it's a flat area. That might not be true, okay? You can pick under drain or not, so on and so forth. One thing I can look at the profile, and we'll see that I ran this assessment. Always show full screen. I ran this assessment. You can see it all drains downhill. And even for the 100-year event, we can see this facility fills up right kind of at the top. There's a little icon here showing that, oh, we're getting within this paving zone. Maybe something we aren't supposed to do based on your local design requirements, right? Well, I'm also not accounting for the fact that this is actually run on a slope, right? So if I was to, engineers love contours. I'll turn some contours on. We can see here in my cursor, you can see the elevation. So this actually runs down a slope. Okay, well, let me perhaps, I can just use a ruler. I can look at the predominant slope for this area. So we'll see here, we got about a 3% slope, 0.03 feet over feet. Well, I should probably change that. So if all right, say that's 0.03, and I can just run this assessment again. This is going to run a whole range of rainfall events and different design ideas that I have. So I'll run this again, and we can look at the exact same thing. Look at the results and see what maybe I wouldn't have thought of before, or maybe I couldn't look at slope in my Excel spreadsheet. Well, now we can. So here's the critical storm, and you can see right here, oh, flooding. Yeah, well, that's an issue. So here's the results for the worst case scenario. And I'll go back and I'll show that flow path one more time. We can see here that I'll jump to the 100-year event. You can see how this all fills up. All right, so it all kind of pops out at the end of this facility and floods out. Well, what we need to do in this case now that we see that it is along a slope, and this is the nature of design, right? We don't get it right the first time. Now, you know what? This is an under drain that connects into this manhole. These blue lines are pipes. Maybe let's add in some sort of inlet or some sort of bypass flow at this point in our system. It's a really common way to adjust and account for different systems in a network. Here happens to be a Raingarden, in all its complexity. Red numbers are something that I typed in manually. So the software updates items for me, but if I type in red, it will stick that number in there. So here's filters, here's a ponding zone. You can see different filter layers. We have all sorts of different outlet types. One thing we could show beyond a table of results, I can look at some details for graphs. Graphs are great. They show us a trend. We can zoom in and take a look at what's happening here. We can look at individual results, one item, right? So if you're trying to communicate to someone that doesn't have a civil engineering water resources degree, well, hey, this is your rain garden. This is what it looks like. So we have a 3D view you could show someone. You can see the under drain, and the natural filtration is actually infiltrates really readily. It's pretty interesting stuff. On this same site, we might have a pond or a swale. This long swale on the edge of our facility captures a lot of our runoff. We can look at the input for a swale. In this case, it has a trench with an under drain, or it could not, right? So again, it's kind of up to you how you want to do this. On the same side, the last thing I'll show is just that there's a pond, okay? Hey, we have a stage storage curve. We have a complex outlet structure, really, really common, okay? We might even get into some more advanced items like under facility base filtration rates, pollution removal, so on and so forth. There's a couple of really great questions here I want to get to. Sasha, in particular, there's someone who's written a couple questions that are perfect to discuss right now. So one item which comes up quite a bit in like in the real world, you get the phone call from the contractor or from the city that something's not working right. One item that this person mentions is a challenge they run into is where ponding occurs. And if is there a safety issue if the water gets too deep? Yes, that is a huge concern. There are a couple items with that. So if the facility isn't designed correctly, right? If the filter material that was used in the design was too optimistic, if what was actually built in the real world doesn't match that, if it wasn't actually constructed correctly, maybe the under drains. I've actually seen this where someone calls out that yes, put 4-inch PVC perforated pipe under the facility, but they didn't actually note that it needs to go anywhere. That was kind of one of those, all right, there's under drains and it will just magically get downstream. Well, the contractor, it was only spelled out to just put them under the facility. Long story short, if these facilities can't drain, well, they kind of flood. All the vegetation is going to die. All the microbes, all of that is going to basically turn septic. So there's going to be a real literal stink on everyone's hands. And of course, if facilities do fill up, there's usually in most every jurisdiction requirements on if a facility stays wet for, let's just say, past 24 hours, if it's past 3 feet deep, as an example, you need to put a fence around it, right? So now you have to have a fence that in and of itself has to be maintained. So to have facilities which aren't fenced, so on and so forth, yes, I've seen that. So perhaps if a facility does flood, kind of that high flow bypass, making sure that it won't get above 18 inches or 2 feet deep is a typical design constraint. Another one where talking about pervious pavement and it gets clogged. Yeah, so specific issue here in California where pervious pavement might get clogged. It doesn't get a lot of rain, therefore it doesn't get a lot of maintenance, doesn't get thought about a lot. And the pervious asphalt one it can be a really great long-term successful win, though every single time I've personally ever seen one fail, whether it's someone talking about it at a conference or whether I've seen one around where I live, it's about education. And all these facilities, it's about, I mentioned, having signs in different languages or for different education levels. There is a playground, let's say I take my child to, and there are some pervious areas. Well, there's signs for kids about, don't bring sand from the sand area onto this area, right? So having education in the community is one way to do that. And, having signage and even, spray painting, right? Like no dumping on those areas. I mean, there's no way to prevent someone from vandalizing something or by accident, dumping soil. But you're right, clogging is, even in very cold states, freeze thaw is nowhere near as detrimental as the potential for having something clog, and vacuuming it is costs money and not going to happen very often. So a couple questions in detail about XP drainage and getting into, in depth into all the different ways to set up drainage design in XP drainage and how these facilities connect, and so lots of questions on that, which is great. Not, I guess, the time we have available today to really dive into this, right? The idea here is that we might have, rain gardens. And we can look at, so this rain garden, I'll show the image, has an under drain and connects out to this manhole. Well, we could set up also kind of a high flow bypass and what that would look like. If you're interested, there's other webinars we've done. I am more than happy, myself and the technical staff here, to talk with your group. So any questions that we just can't get to today in this public setting, by all means, let us know. We can dive into it. So one more question here looks like about underground. What's the difference between underground storage and a dry well from a treatment perspective? So good question. Well, they might be semantics, they might not be. So a couple things. Typically when we start having a dry well, it's kind of a contained system. Sometimes maybe there is a, the bottom of the facility is open, so there can be infiltration. So I have a whole list of stormwater controls here. I can maybe just add in an arched chamber facility. I'll add one right here, let's say. Maybe I'll redraw this kind of down the street. Okay, so here's chambers. You'll see with chambers, well, you buy them in complete units, right? So I can't, you can see I can change the footprint. It's going to snap to like a full size. I mean, you can try, but I don't think anyone's going to sell you 3 3/4 chambers, right? So here would be an example of an underground vault structure. The idea that maybe this is all, this whole thing is open, right? So maybe I'll actually just delete that. And I'll say that this might be 524 for the base level. You see how this, so this is pretty common for these underground detention chambers. You have all sorts of different types, but there's fill space, which can be used as storage around them as well as inside, versus like a rain barrel or a dry well. It depends, right? So I don't know, I think of a dry well as being a much smaller structure. And well, a very, very small structure won't do me a lot of good. That's why they often are very deep. That would be those underground injection wells. And then the deeper you make them, the more likelihood of being in the groundwater table, then you're in trouble. So usually these are much broader, flatter structures versus a deeper, smaller footprint well, if that kind of answers the question. Let's see here. So something actually that came up this morning as well. I think I've kind of hit a bunch of these questions here. So this one is, what do you basically do if you have high groundwater table and you have facilities with just really poor soils, right? Poor draining soils, right? Class C, Class D soils. What do you do? Well, kind of in the example of the steep roadway, right? Well, you don't want to have a rain garden that will infiltrate on a steep slope because you might wash the road away. Again, that's a phone call you do not want to get. So you might have to wrap those facilities up. So if you have an intermittent groundwater table, you have to worry about buoyancy, kind of a funny idea, right? But like if you have a really high groundwater table and if you wrap the base of a facility, you can buy soil, right? You buy media to do the filtration, but just wrap it up so it's not inundated from the in situ soil. That's one way to do it. But obviously you have to be creative, maybe, and have broader, flatter structures instead of deeper. Okay, one really great question. I actually don't see this mentioned very often. Okay, so last question I'll get to today. With these vegetated structures, right? We're treating pollution, right, with the soil. What in the world happens in the long run? Well, I guess this person is spot on that, won't that soil in the long term basically kind of fill up with pollution? And yes, it will. That's absolutely what will happen. And, it's the point, but it's something in kind of the O&M plan, right? It's not just, okay, we went and we bought washed sand and we got some filter material. We're done. We planted some plants and great. Just as long as you, trim those plants back, reasonably every 6 months, you're good for 60 years. No. What you might want to do, and some cities are starting to do this, is your O&M plan is to replace that soil. And that will probably have to go to a special landfill, right? Because it's probably going to have heavy metals in it. Now, that might seem like a burden. Well, that means the heavy metals are getting trucked somewhere that's a designated zone for it, as opposed to just washing right out into my streams or, you know, into other areas, again, where my child might play. It's in a kind of a quarantine zone, so to speak, in this planter box that no one's going to play in. But yeah, over 15, over 30 years, those facilities may begin to accumulate, you know, beyond just sand and grit. That's something you'll probably see visually and be able to maintain that. It's you know, the unseen stuff, right? Really high in phosphorus, really high in heavy metals from brake pads. Okay, awesome. Oh, there's some more questions pouring in here. Okay, one very last thing I'll say, I know we're getting on in time. One very last thing I'll say is the idea of 2D. Is there a two-dimensional component to XP drainage? You know, the design and the hydraulic analysis. It's a, you know, fully flexible one-dimensional analysis that we happen to have a very, very you know, basic 2D assessment we can have in the software. I actually was meaning to show it before. So one thing I can do, I have a surface loaded here in XP drainage. Really interesting thing to do, just kind of set out our planning for our site. I'll turn the image on. Because I have a surface, I should be able to, I'm going to call it deluge the site. And I'm just going to say, you know, put 2 inches of rain on this site, see what happens. Okay. So here is a two-dimensional map of where that water moves. Now, this tool is not running, you know, a full FEMA approved flood mapping process. We have other tools that do that. This is more from a planning point of view, showing us water is gonna drain naturally to this, basically the edge of our site. Maybe a good place to put a long collecting swale so that we can maintain the natural drainage paths, you know, without having to mass grade this till the end of time, okay? So that's a two-dimensional component here of XP drainage, using this planning kind of point of view. Or I use this to delineate my catchments because I like to see arrows showing me what to do. Okay, again, thank you everyone for joining. If there are questions I didn't get to, I feel like I covered a bunch. Anything I didn't get to, by all means, again, my name is you know, Zach Sample. Reach out to me, reach out to us. We can absolutely talk more, and maybe, you know, other colleagues there, we can talk about your projects and XP drainage if you're interested. Again, thank you very much, everyone. Please have a nice day.